All right, here we go. Reviewing your flowcharts. Now, on your flowcharts, you've got a couple of boxes underneath this one, right? You've got the perfect squares, and then I'm pretty sure I put the perfect cubes there, right? You're gonna need those because we're gonna do cubics today. Aren't you excited? Listen to the roar of the audience. All right, let's let's do some review. Remember, the first thing you do when you factor is what? That's right. Check to factor out any common terms or factors or whatever you want to call it. This is a general trinomial, right? Because it has three terms. General trinomial. And since you can't factor anything out, you're going to go right directly to the guess and check and factor it. Okay, number two is a difference of squares. It's two factors or a binomial, and you have to check. Now you're going to have to check to see if it's cubes, okay, after today. So this is a difference of squares. Remember to rewrite these as it helps. Trust me, it helps. As 2 squared x squared minus 3 squared. And then I like to define my a, which is the base 2x, and then my b is the base 3. Then it's a lot easier to put it in your a plus b, a minus b form. And of course, the one that students always miss, and sometimes even myself, factoring out common terms first. Okay. Look at the numbers. You can take out a factor of 2 and look at your variables. In this case, I can take out an x and I can take 2x squared divided by 2x is x. This has two x's, right? This is 2 times x, 2x squared. And then this is 10x. So I could take out a 2 and then one of the x's. So if I take a 2 out of the 10, I have 5. Okay? All right. You guys ready to do some super fun stuff? Well, at least you guys are talking. In my last class, they didn't have enough coffee. All right. So looking at number one, you got to have to look at your perfect cubes and notice that 27 is a perfect cube, right? Now I got these little chart things that I usually make up, but of course, Mr. D forgot them at home. So I'll try to make some up here at school. 27 is a perfect cube. It is 3 cubed. Okay? I'm still going to define my A and B. My A is the base X, and my B is the base 3. So as I went through my flow chart before I started this problem, factoring out, hang on a sec. Anyway, I couldn't factor out any common terms. I have a binomial, so it's one of these three. This happens to be a sum of cubes, so I follow this formula here. So I have a plus b, because this is a sum. So a plus b, so I have x plus my b is 3 times a squared. Now, this one, it doesn't matter, but when I have a coefficient of x, I got to be a little careful. So I have x squared minus a times b, which is 3, plus b squared. And then I have to simplify this and put it in the right order, right? Okay, hang on. Well, let's try a different problem and see if it comes to you. Okay. So I have my x squared. Um, we usually put the coefficient in front, right? So 3x. And then 3 squared is 9. So I was following this sum of cubes. Okay. That's my sum of cubes. This is a cube and this is a cube. Okay, this is x cubed. 27 is 3 cubed. That's fine. So this is a sum of cubes. So I'm just following this factored form. Okay. All right, number 2. Um, I know 25 and 36 are perfect squares. Okay. 25 is 5 squared. 36 is 6 squared. What about this x to the fourth? Is there any way I can write that where it's a squared? You're on the right path, okay? I definitely want an x squared to have a perfect square. That gives me a perfect square. But remember, that's to the fourth. How can I write x squared equal to x to the fourth? Yeah, just square that. Okay? So I have x squared squared. Yeah, this is kind of tough stuff. Okay, so let's define our a. What's my base here? Close, 5x, but don't forget, this is my base, and this is my base, right? That's what's being squared. So it's x squared. All right, my b, 6. 6 is being squared. So then I'm going to go to my difference of cubes, or I'm sorry, difference of squares. Okay, I have my a squared minus b squared, and that factors to, quiet down, that factors to a, which is 5x squared, plus b, so plus my b, which is 6, and then my a, 5x squared minus b, which is my 6. So we actually did the same thing with our cubic as we did uh, with our squares, except it's just one more step because we have, obviously cubics are longer. Questions? You know what? Let's take a look at your homework for a sec. Let's do number 5, okay? Because we don't have another one example in your note packets like number 1. So let's do number 5. Are you ready? Okay, so I have, this is, again, if we follow our flow charts, we have two terms. We don't have squares. We have cubes again. And we have a sum of cubes. So it's pretty much the same problem as number 1. 27 is what cubed? 3 cubed. Okay. So just like my difference of squares, we're going to define our a and b, right? What's being squared here? Yeah, just my base m. What's being squared here for my b? So I have a plus b. And here's my factors. Started my factors.
This is literally the same problem with a different letter.
Yeah, pretty much. So I have my a plus b, which is m plus 3. Okay, then I have a squared. So my a is m squared minus my a times b. Here's my a times my b is 3 plus b, which is 3 squared. In fact, it's exactly the same problem, right?
Are we doing the backside today as well?
Yes. I'm going to, well, maybe not.
I'm trying to ask this question.
So I have m plus 3, clean it up, m squared, and again, I want my 3 in front. Yeah, this is exactly like the other problem, right?
Swap the x.
Swap the x for the f. Does that help kind of running through it again, clear it up a little bit?
Well,
No. All right, let's do another one. Let's go on the back of your note sheet. Okay, I'm going to, again, when we follow the flow chart all the way through, we end up with a difference of cubes, right? 27 is 3 cubed, x cubed, minus 1 is just 1 cubed. Define our variables. What's our a? 3x, right? What's our b? 1. So if we look at the formula for difference, um, it's just the sign change for the first two, right? A minus b. So I have a 3x minus b, and then we have a squared. Now we got to be careful here. A squared. So my a is 3x. Do you see it now?
Yeah.
Okay. So I have 3x squared. Remember, when we have a square outside parentheses, what do we have to do? Distribute, right? So I have 3 squared x squared, right? You with me?
I,
3 squared x squared minus a times b.
why are we squaring the a by 2?
We square the a.
I'm,
A squared.
I'm, I'm sorry.
It's part of the formula. Okay? We have a cubed minus b cubed equals a minus b times a squared plus a times b plus b squared.
Basically, it's almost the opposite of that.
Yeah. The only difference is this is a plus and that's a minus. Okay. So Aiden, we're doing a squared.
I guess so.
Okay.
I'm supposed to get help with this.
Doing a squared. Now the next one is a times b. So we're going to take our a, 3x, and then we're going to multiply it by b, which is 1. add b squared. So my b this time, 1, and we have to square it. Then we have to simplify this. So I have my 3x minus 1. 3 squared is 9x squared minus, let's see, 1 times 3 is 3, and I have my x, plus 1 squared is just 1. Now, after we factor these, sometimes these quadratics, like we had that quadratics even in that binomial, sometimes you could factor these down even further. They'll throw a wrench in there once in a while, and sometimes you have to factor these. Even though we factored it once, sometimes you have to factor it again if it's a quadratic. This one does not factor any further, so keeps cutting. It shows up on my screen, so if it cuts off, please let me know. I think we'll stop here because cubes are a lot. They're a lot to take in. Okay, so we'll call this part one. We'll call it part one. So for homework, you can do problems 1 through 10, but tomorrow we'll do factor by grouping. So you'll have some time tomorrow to do this too. Okay? But try to get some done today. You've got, 10, 15 minutes, whatever. Try to do some of this homework today and don't leave it all for tomorrow. Are you guys good? All right.